Hi everyone, this is Mrs. Snowback. Today we're going to do Unit 9, Lesson 5, and we're going to start volumes. So volumes of prisms and cylinders. So before we start doing some actual volumes, it says number 1, find the surface area of this solid. And so surface area is any area you can touch, and this is a prism, so you could use the formula pH plus 2b. Let's just quickly do this. So the perimeter around the base, if you think about the base being the bottom, it's going to be 6 plus 4 plus 6 plus 4. So I'll just jot that down. And that is 20. And then the height of the object would be the 2 over here. And then let's see, B is the area of the base, which is going to be 6 times 4, because it's a rectangle down there, so that's 24. Plug everything you know into your formula. Just grab a different color. So surface area would be P, which is 20, times H, which is 2, plus 2 times 24. So if you add all of that up, it's going to be 88 units squared. 88 units squared. So I want to show you something. If we look at this picture and we look at the top, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then if you look at the front, so there's 24 squares on top. And then on the front, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 on the front. And then on the side, there's 1, 2, 3, 4, 5, 6, 7, 8 on the side. So if you double that, because you know the top would be the same as the bottom and the front would be the same as the back and the right would be the same as the left. So if you add those together, 24, 12, and 8, you get 44. And then if you double it so that you get the other three sides, you get 88. Interesting. Our surface area was 88 units squared. Now I want you to think of the shape of these objects. This right here is a square. There are literally 88 squares that cover the surface of this prism. 88 square units. Okay, so keep that in mind. Next, let's go to number 2. So I'm going to erase some of my stuff here on my box. All right, number 2 says find the volume of this solid. And although we haven't talked about how to find a volume yet, you might recall from years past, to find a volume of a box, you can do a thing called length times width times height, if it's a rectangular box or a rectangular prism. So we can do 6 times 4 times 2. 6 times 4 is 24. 24 times 2 is 48. And when you label volume, you're going to use units cubed, or in other words, raised to the third. Now I want you to think about this object right here, and I want you to think about the top layer of this object. On the top layer, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's literally 24 cubes. If I color that in so you can see it here, color that cube in. There's 24 cubes on that top layer. Well, there would be 24 cubes on the bottom layer as well, and 24 plus 24 is 48. In other words, it literally would take 48 cubes to build this object. Is it starting to make sense where the labels come from? It would take 88 squares to cover the outside, and it would take 48 cubes to build this object. Our focus today is finding volumes of prisms and cylinders. And here's the formulas. Volume for a prism is going to be area of the base times the height of the object. B stands for area of the base. H stands for height of the object, which in this case is a prism. So think about having this rectangular prism right here, and let's say you pour it full of chocolate milk. You're going to start by putting a thin layer of chocolate milk on the bottom, and then it's just going to fill all the way up. You're going to multiply that thin layer on the bottom times the height, and you would fill it up, and that would be its volume. Okay, same thing for cylinder. Fill up the bottom of the cylinder. Well, the bottom is a circle, so that's pi r squared, and then multiply by the height. So basically the same formula, it's just that for a cylinder it's always a circle, so you can be more specific. Remember, r means radius, and h is still the height of the object. Number 3, let's find the volume of this prism. First of all, formula. Area of the base times the height of the object. Where is the base? Think about that for a minute. What is the base of this object? It is not the bottom. Remember, the bases have to be parallel and congruent. So in this case, the two shapes that are parallel and congruent are the triangles. So I'm just going to make a note of that. The base is the triangle. Okay? All right, so if we want to find the area of one of those triangles, to find the base area of a triangle, you're going to have to do little b times little h divide by 2. And you want to pick the two sides that are perpendicular. So I'll do 12 times 10 divided by 2. That's 120 divided by 2, which is 60. Now think about the height. The height is described as the distance between the bases. So where are the bases? Now find the distance between them. 11 is your height. 11 is the height. It's laying on its side. Cool. Now we have everything we need, so we can do volume, which is going to be 60 times 11. And 60 times 11 is 660 centimeters cubed. If I filled this thing up with cubes, that's how many cubic centimeters it would take. 1 centimeter by 1 centimeter by 1 centimeter. Great, let's find number 4. Let's find the volume. It is a prism again. Volume is area of the base times the height of the object. What shape is the base? Much like before, the bases are the triangles. This is a lot like number 3. The difference is we don't have that side over there, so it's going to be a little harder to find the area of the base. One thing I do notice is the 15 here is going to be the same here. So I can put a 15, and now I can do Pythagorean theorem. X squared plus 9 squared should equal 15 squared if I use that pink triangle. X squared plus 81 is 225. Subtract your 81. And x squared is 144. We don't want x squared, we want just x, so you're going to have to take square root, and x is 12. So the nice thing is I can erase this little x, and I can put a 12 over there. Now I think I can find the base area. The base is a triangle, so I'm going to have to do little b times little h divide by 2. So it's going to be 9 times 12 divide by 2. Well, half of 12 is 6, and 9 times 6 is 54. So area of the base is 54. The height of the object, remember this is described as the distance between the bases. So think about where is the height. It is not 12. It's the 10. 10 is the distance between the two triangles, so 10 is your height. All right, we have what we need. Area of the base is 54. Height is 10. Multiply those together, you get 540 feet cubed. That's how many cubic feet it would take to fill up this object. Find the volume of this pentagonal prism. It's a prism, so area of the base times the object. Area of the base. The base is a pentagon. So let's think about that. Normally, for a pentagon, we're going to have to do the 6 steps. However, if you think about dividing this into triangles, we already know this side is 5, so this side is 5 as well. And then this little red dotted line that you see right here, it says it's 3.4. That's the height of the triangle. So guess what? Yes, we have to find the base area and the area of a pentagon, but they've already done the first 4 steps for you. So next, what you would do is find the area of the triangle, which is going to be 5 times 3.4 divided by 2. So this is already like step 5 of the process. So if you do that, let's see, I believe you get, let me type it in here quick, 5 times 3.4 divided by 2, you get 8.5. So the area of one triangle is 8.5. And then how many triangles would it take to fill up a pentagon? Well, it would take 5 of them. So then multiply that number by 5 and you get 42.5. So 42.5 would be the whole area of the pentagon, or in other words, our base area. That wasn't so bad. Okay, next we have to find the height. The height is the distance between the bases. In this case, the distance between the 2 pentagons is the 8. 8 is the height of the prism. So volume equals 42.5 times 8. And that comes out to be 340. And then think about your label. It's a volume, so it's millimeters cubed to the 3rd power. Please find the volume of this cylinder. Okay, so volume of a cylinder, it's area of the base, but the base is a circle. So it's pi r squared times height. I think we have all the values that we need. I think r, the radius is 3, and h, the height is 8. And pi is just going to stay pi. So volume equals pi 3 squared times 8. And you would type that in your calculator, so go ahead and try that. Practice typing it in. And I got 226.2, and it would be centimeters cubed. Let's find the volume of this cylinder. So volume of a cylinder is pi r squared h. So think about, what's r? Well, 10 is the diameter, so we're going to have to cut that in half. So our radius is 5. Next, we need the height of the cylinder. Now, this cylinder is laying on its side, so the height is actually going to be sideways, all right? It is not the 16. 16 is not perpendicular to the base, so our height would be kind of where I've marked it there. I think this would be a 90-degree corner, and so we can do a little Pythagorean theorem. We can do a little height squared plus 10 squared is going to equal 16 squared. And remember, the 16 is across from the 90, so that's going to be your C. In your, you know how we do a squared plus b squared equals c squared? Well, the c is always the hypotenuse, or in this case, it's the 16. So we have h squared plus 100 equals 256 minus 100 from each side. And you get h squared equals 156. But we don't want h squared. We want just plain old h, so square root. And h is 12.4899. So I'll just say 12.49. And let's see, is that all we need? We have our r, we have our h. Yeah, that's all we need. So volume is going to equal pi 5 squared times 12.49. And go ahead and type that into your calculators. And I just left the decimal for 12.49. I just left that whole decimal in my calculator and built off of that. And I got 980.96. 980.96. And that is centimeters cubed. Now, real quick, if you had rounded differently, if you had rounded to 12.5, let's say, your answer would have been 981.7. So it's a little different depending on how you round. So as long as you're close to my answer, if it's slightly different, it's just your rounding. Imagine you have your favorite color of Play-Doh and you have a hunk of that Play-Doh right now in front of you. And let's say I tell everybody, everyone, take your Play-Doh and please form a right rectangular prism. And so you're like, okay, you're taking your Play-Doh and you're smushing it around and you're making nice crisp edges and you end up with a prism that looks like this. Okay, that has a certain volume, right? Now let's say I tell everybody, all right, take your prism and make it oblique. So you take your prism and you push it over so that it's kind of like the Leaning Tower of Pisa, right? Is the volume different? Did the volume change? The answer is no, because you still have that same chunk of Play-Doh. You still have the same amount of stuff. You just tipped it over a little bit. So if two solids have the same height and the same cross-sectional area at every level, then they're still going to have the same volume. Number 8, find the volume of an oblique hexagonal prism if the height is 6.4 centimeters and the base area is 17.3 centimeters squared. Look for your key words. I see volume, I see prism. That's going to help you figure out what's your formula. Volume for a prism is area of the base times the height of the object. Oh boy, our base is a hexagon. Normally this would mean we would have to do the 6 steps. But look closely at what they gave you. They gave you the base area. What? They did all 6 steps for you. So we already know the B. We don't have to do any of that work. The other thing we're going to need is the height. Look at that. They gave us the height as well. The height is 6.4. So you guys, there's really not much work involved in this. You're just going to multiply area of the base times the height of the object. And when you multiply 17.3 times 6.4, you get approximately 110.72, and it's centimeters cubed. Volumes are always units cubed. Number 9, last one. Prisms A and B have the same length and the same width, but different heights. If the volume of prism B is 150 inches cubed greater than the volume of prism A, what is the length of each prism? So you guys, I want you to pause the video right now and I want you to spend some time on this. I want you to see if you can figure this one out. It's a good thinking problem. So your job is this distance and this distance are the same. The lengths and the widths of those bases are the same, but the heights are different. And so you want to figure out if the volumes are different by 150 cubic inches, what would those lengths have to be? So pause the video, mess around with this for a little bit. So there's many ways to do this, but I'm going to walk you through how I think about it. They say the volume of B is different from the volume of A by 150 cubic inches. So if I took a difference or subtracted them, I should get 150. Now think about, how do you find the volume of a prism? Well, it's area of the base times the height of the object. So I want you to find the area of that base for prism B. Well, to find the area of the base, we would have to do 4 times x. And then multiply that times the height, which is 10, and you'd get the volume, area of that base times the height. Same thing with prism A. Find the area of the base, which is going to be, again, like I want the area of this, so I'm going to have to do 4 times x. So I'm going to go 4 times x, and then times the height, 7. That would give me the volume of prism A. And it's still supposed to give me a difference of 150. Cool. Simplify. 4x times 10 is 40x. 4x times 7 is 28x. Equals 150. We still have the 150 over there. 40x minus 28x is 12x. And then to solve for x, we would divide by 12. And it turns out x is 12.5. So in other words, the length of both of these is 12.5 inches. And that is your answer. Now, could you have used guess and check? Yes, you could have used guess and check, and I'm guessing a lot of you did. I'm just going to erase these x's because what we just figured out is this distance is 12.5 and this distance is 12.5. That and that are the same. Next, will you please try Unit 9, Practice 5? If you need help, let me know. Have a great day.